Hi everyone, welcome back to Array series. Hope you're doing good. This is Mahesh. In this video, we are solving Leetcode problem number 238, which is product of array except self. Let us look into the statement of the problem. So given an integer array nums, return an array answer such that answer of I is equal to the product of all the elements of nums except nums of I. Okay, the product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. And you must write an algorithm that runs in O of n time complexity and without using the division operation. Okay, so this one we need to keep in mind. So we should not use the division operation. Okay, they have given some examples, and if you see the constraints, there will be at least 2 elements in the array, and max is 10 raised to 5. The length of the array lies between 2 and 10 raised to 5. And if you see, any number in the array will range between minus 30 to plus 30. Okay, the input is generated such that answer of I is guaranteed to fit in a 32-bit integer. So basically, after the multiplication also, the number won't exceed 32-bit integer. So we don't need to worry about the big number. Okay. So with this, let us switch to our editor. So what they have given this particular array. So now what we need to do, we need to take one more array. Then now at the place of 1, we need to multiply 2, 3 and 4. Then we need to add that here. So if it is 2 into 3 into 4, then it is 24, correct, right? So now what I will do, I will add 24 here. Then at the place of 2, we need to consider 3, 4 and 1. So it will be 12, right? So I will add 12 here. Then in place of 3, I should consider 1 into 2 into 4. So basically I am excluding that particular number and I am considering all the remaining numbers in the array. So this will give 1 into 2 into 4 will give us 8, correct, right? Now after that, now if you exclude 4, remaining numbers 1 into 2 into 3, which is 6. So this is what is expected out of this particular problem. And also we are clear about the constraints. So the length of array will be between 2 and 10 raised to 5. So as per our standard Leetcode criteria, so if at all we try to solve this particular in O of n square, then it will give us TLE, correct? So we should try to solve this particular problem in O of n time complexity. Okay, so what they have mentioned, we should not use the division operator. So if that was not the case, then what we would have simply done, we would have considered 1 into 2 into 3 into 4. So the entire array we would have multiplied once. So we will get 24. Now using this 24, take the answer array, then consider first number, just divide that number, divide 24 with that particular number. So which will be 24 divided by 1. The second number would be 24 divided by 2 and the third number would be 24 divided by 3. Basically it is not the index of the number, it is basically the number itself here. Okay, so now the last number will be 25 divided by 4. This would have given us 24, 12, 8 and 6. But the constraint says we should not use the division operator. Okay, so if that is the case, then how to solve this one? So maybe what you can do, you can pause for a second and you can think for any possible solution, then you can come back to the video. So with that, now we also understood the idea or the intuition behind this particular problem, right? So basically we need to solve this particular problem in O of n time complexity. They have clearly mentioned that in the problem statement as well. With that, now let us try to understand the brute force solution for this particular solution problem. So basically don't consider what time complexity we will solve this problem with, but we will try to give some brute force solution. So it clearly says, right, if at this particular value we want, then we will have to leave this number and we will have to consider other numbers. We will have to consider other numbers and we will have to multiply them. So if I want the number at this particular place, then I will have to leave this number, then I will have to consider other numbers. So we will use the same logic. So now what I will do, so I will take an array, okay, then for the first number, I will leave the first number, I will consider the remaining numbers. These are the remaining numbers. So I will say 2 into 3 into 4. This is my first number. Next, for the second number, I will leave this particular number and I will consider remaining numbers, that is 1 into 3 into 4. Okay. For the next number, I will leave that and consider remaining number. So it will be 1 into 2 into 4. Then for the last number, it will be 1 into 2 into 3. So this is how we can come up with the answer array. So now it will give us whatever the answer we are looking for. So with that, so what I am doing, at any point I stand and I will consider the remaining numbers. So I will ignore if that number is the same, if that index is the same as the index where I am standing. So with that, let us try to come up with the pseudocode for this one. So now what I will do, I will say our answer array or maybe our result array. So result array. So n will be our nums dot length. Now our result will be new array, okay, of length n. Okay, with that, now what I will do, I will use a for loop for I equal to 0. Okay, that's how, we see what we are trying to do. We are trying to stand at any number, then we iterate over all the numbers. Then we stand at the next number, again we iterate over all the numbers. Then we stand at the third number, then we iterate over all the numbers. So basically we use two loops here. So one to stand at a particular index and look towards left and towards right. So that only I am trying to mimic. So I equal to 0, I less than n, I plus plus. Okay. Next, another loop will be for j equal to, again it starts from 0. Okay. Then j less than n, j plus plus. Now here inside this for loop, I will check if my I is not equal to j, it means I am ignoring the self number. So this basically ignores itself. Okay. Then if this is not the case, then what I will do, but before this, I will have to consider product equal to 1. Okay. Then I will say my product equal to product into nums of j. Okay. This way I will multiply. Then at the end of the first for loop, what I will do, I will say my answer or result I have taken. So I will consider result equal to, or result of I equal to my product. Okay. So with this, finally I will return my result. Okay. So if you have seen, for each number we will iterate for we iterate for n number of times. So there are n numbers and for each number we iterate for n times. So our time complexity becomes O of n square. And if you see, our space complexity is O of 1 because, we are using our results array. So it becomes O of n. Correct, right? So, but what they say in the problem, if we are using this particular array to store the output, then we can consider this as in place only. So considering that, it becomes O of 1 space complexity. Okay. So if you see now, this will take order of n square time complexity, so which is costly, And we have also seen that our input ranges between 2 and 10 raised to 5. So our solution will give us TLE in the Leetcode. So we need to improve this particular solution. So how to do that? Now again I will take my array. So 1, 2, 3 and 4. Okay. So now if I want, let us assume if I want the number in my results array for this particular place, then I need this prefix product, correct, right? And also I need the suffix product. So basically it will be 1 into this product will be 12. So this 12 is used to place at this particular position, correct, right? So if that is the case, we are relying on the prefix product and suffix product, correct, right? Now if you know at any position, when you are standing at any position, if you know the prefix product and the suffix product, then we are good, right? I mean, we can simply multiply them and we can place at this particular index. So considering that fact, now what I will do, I will first take a prefix product array. Okay, then what I will do, I will consider 1 as our prefix, initial prefix. So prefix will be 1, because if there is nothing before 1, then we will consider here we have 1, and after this again we will consider there is 1. Okay, so with this we will start. So what will be the prefix product for this particular one? Since this is a first number and there is nothing out, towards its left, then we will simply consider 1 and we will place it here. Okay, next one, for this particular number or for this particular place, then it will be this particular, whatever the prefix, this number and its prefix product, correct, right? So its prefix product is 1 and this number is 1. So 1 into 1 will be 1. So I will take that number and place it here. Okay, now after that, now if I stand at this 3, then it will be this number into the prefix product of this particular number, because it is basically 1 into 2, correct, right? So now what I will do, I will take 1 and this number, so which is 2. So basically 2 into 1 will be 2, correct, right? So I will place that 2 here. Okay, with that I will move to my last number. Now if you take last number, then for me the prefix product of this particular 3 multiplied with this particular 3, that will give me the overall prefix product for 4. So that will be 3 into this 2. So 3 into 2 will be 6. So this will give us prefix product. Now I will also take another array, suffix product. Then now I will not start from the first number because I need the suffix product, right? So I will start from the last number, then move towards the left. So for last number we can simply take 1 because there is nothing outside that, correct, right? Now after this, my suffix product will be, for the next number, it will be this one into this particular number. So basically 4 into 1, which is 4. So I will take that. Okay, next for the next number 2, it will be this number into its suffix product. So 4 into 3, which is 12, correct, right? Now for 1, it is 2 into 12, 2 into 12, so which is 24. Now if you see, we got prefix product and suffix product, then our result array will be simply product of these two, so which is 24, product of these two, which is 12, product of these two, which is 8, product of these two, which is 6. Correct, right? So this is how in one iteration we will find prefix product, and in another iteration we find suffix product, and then in one more iteration we will finally arrive at our result. Okay, so with that, let us try to look into its pseudocode. So now what I will do, n will be nums dot length. Okay, then prefix product equal to new array of length n. Correct, right? Then suffix product equal to same new array of length n. Okay, now what I will do, first I want to find the prefix product. So first I want to find the prefix product. If that is the case, what I will do, I will say prefix product of 0 equal to 1. So this I will initialize because there will be nothing on the left side of the 0th index. Okay, now I will start from index 1. So for I equal to 1, I less than n, I plus plus. Now what I will do, I will say prefix product of I equal to prefix product of I minus 1 into nums of I minus 1. Correct, right? So that's what we did. We took the previous number and its prefix product and then we multiplied. So this will give us the prefix product. Okay, now in the same way, we will also need to find the suffix product. So that we will start from the right. So our suffix product of n minus 1 will be 1. Correct, right? This is our initialization. Then we will start from for I equal to n minus 2. Okay, then I greater than or equal to 0, I minus minus, then what we will do, suffix product of I plus, sorry, I equal to suffix product of I plus 1 into nums of I plus 1. Correct, right? And this is how we get our suffix product. Then finally, what we will do, we will take another array, result equal to new array of length n. Then what I will do, I will say for I equal to 0, I less than n, I plus plus, I'll simply multiply prefix product and suffix product and I will add it to results array. So result of I equal to prefix product of I into suffix product of I, and finally I will return my result. Okay, so this way we will be able to boil down the time complexity from O of n square to O of 3n here. Correct, right? Why? So 1 to find the prefix product, this is O of n. Again for suffix product it is O of n. Then for finally finding our results array, we need again O of n. So basically it is order of 3n time complexity. Okay, but if you see the space complexity, we are taking suffix product and prefix product arrays and then results array. So if we ignore results array, considering the statement, we need O of 2n extra space complexity. Correct, right? So this is our better solution, but it is not still the best solution. With that, let us try to execute this and see. Let's take a variable int n equal to nums dot length. After this, let us take the array prefix product, which is int array prefix product equal to new int of length n. Okay, then initialize the first value with 1. Then after this, I will copy paste the same lines. I will make this suffix product. Then I will initialize suffix product of n minus 1 with 1. Okay, with this configuration, I will start building my prefix product. So along with this, I also need one more array. So I will take that here. So it will be our result, which is of length n. So here from I use a for loop for int I equal to 1, I less than n, I plus plus. Now what I will do, I will say prefix product of I is equivalent to prefix product of I minus 1 into nums of I minus 1. Then I will again copy paste these lines for suffix product. So I will say suffix product, then I will copy this array name. It should be I plus 1. This also should be I plus 1. Our I starts from n minus 2 this time. Then I greater than or equal to 0, I minus minus. This will build us the suffix product array. Then I will build my final result array. So I will use for loop for int I equal to 0, I less than n, I plus plus. I will say my result of I will be equal to prefix product of I into suffix product of I. So with this, finally what I will do, I will return my result array. With this, let us try to run and see. This is accepted. I will submit. Our solution got submitted successfully. What I will do, I will take directly our result array. So it will be new array of length n. Okay. Then what I will do, first I will find our prefix product. Okay. So if it is prefix product, then we start from the first number, correct, right? So if that is the case, there will be nothing on the left side of the first number. So what I will do, I will take a variable product or prefix product, then I will assign it with 1. Okay. Now what I will do, I will start using for loop for I equal to 0, I less than n, I plus plus. So here assuming 1 is at the left of our 0th index. Okay. So now what I will do, I will first say my prefix product for 0th index will be this one, correct, right? So now my result array contains the prefix product in the first iteration. So it will be our prefix product. Okay. After this, I need to find the next prefix product, right? So I need to update this value. So my prefix product will be the current prefix product multiplied by nums of I. Okay. So with this, our prefix product gets updated, and in the next iteration when we put the value at result of I, then the current prefix product which is relevant to the I plus 1th index will be added here. So this way we will put the prefix product. Then after that, what we need to do, again we need to do suffix product now, right? So this suffix product, we need to multiply this with prefix product. So what I will do, I will take a variable suffix product and I will assign this to 1. Okay. Now what I will do, I will use a for loop again, I equal to n minus 1, I greater than or equal to 0, I plus plus. Now what I will do, I will say result of I. So at the index or at the n minus 1 place, already our prefix product will be there in the results array. To that, what I will do, I will simply multiply with my suffix product. So result of I multiplied with suffix product. Okay. After this, I will update my suffix product equal to suffix product into nums of I. Correct, right? This is pretty much simple and straightforward. Then at the end, finally, I will return my result array. So now if you see, we use this iteration or this O of n to compute the prefix product, and again this to finally multiply the suffix product and place the number at the right place. So with this, our time complexity will be of order O of 2n and our space complexity is of order O of 1, because this result array will be treated as in place array. So in this particular example, that's why it is of order O of 1. With this, let us try to execute this and see. What I will do, I will remove this part and I will remove this part here, remove this part. This is not required. Okay, now I will only retain my results array. So next I will say int prefix product equal to 1. Then I will start my I from 0. So first I will say my result of I will be equal to my prefix product, and after that my prefix product will be equal to prefix product into nums of I. This will give us the prefix products in the same result array. Then what I will do, I will use the next array which starts from n minus 1. Then I will use my this statement result of I equal to prefix product into our suffix product. So if I want to use suffix product, then I need to create a variable here. So I will say int suffix product equal to 1. Okay, then after that my suffix product will be equal to suffix product into nums of I. Okay, with this finally I will simply return my result. This will be result of, so this should not be prefix product, it should be result of I, because that variable we cannot take it here. I mean, that will be wrong. It will only be having the last prefix product. So it should be result of I, because our result of I will be holding our prefix product. Okay, with that, let me run. It got accepted. Let me submit. So the solution got submitted successfully.